Alright, in our last video we did arithmetic sequences, and now we're going to look at series and arithmetic series. And so a series is just the sum of a sequence, and an arithmetic series is just the sum of an arithmetic sequence. Alright, and so there are two types of sequences and series. There are finite and infinite sequences and series. And so a finite sequence is a sequence or a series that comes to an end. And so a finite sequence, an example of a finite sequence would be something like 3, 6, 9, 12. And so this is a finite arithmetic sequence because it's going up by 3 and it ends. There's no ... or one of those ellipses at the end. A series, this same sequence in a series would just be 3 plus 6 plus 9 plus 12. So a series is separated by pluses and a sequence is separated by commas. So series is just the sum of those terms in the sequence. Now an infinite sequence or series is a sequence or series that never ends. Okay, and like I said, that'll be represented with a ... on the end. And so this, an infinite sequence, would be something like 2, 4, 6, 8, ... An infinite series would be 2 plus 4 plus 6 plus 8 plus ... And so the infinite is going to be represented by this ... here. Now, this is not to be confused with something that does this. 2, 4, 6, ... and then maybe doesn't end at 8 because that would be the next term. So let's say that it would end at 20. So if an ellipse is in the middle of two numbers, this would not be infinite. This is not infinite because this just represents that there are numbers in between 6 and 20 that follow the same pattern until I get up to 20. So the ellipse has to come at the end if it's going to be infinite. Now, sometimes we want to add up numbers in a series, and so if I told you to add up the first 4 terms of this particular series, that'd be easy to do. I could add those up in my head pretty easily, and that'd be 20. However, if I wanted to add up something like the first 50 terms and find the sum of the first 50 terms, I would not want to first find the 50 terms and then second add them up. That would just be a pain in the hind end. So, just like we had a formula to find the term in an arithmetic sequence, we have a formula to find the sum of an arithmetic sequence, and I forgot that there was this example first, so we'll do this example first and then get on to that formula. So basically this is just telling whether these are infinite or finite sequences or series. And so this first one is going to be infinite, and this is going to be a sequence, and I'm just going to abbreviate. I for infinite, F for finite, and then sequence or series. This is going to be a finite series because I've got pluses. This is going to be a finite sequence because I've got commas, and then this would be an infinite series. Now, getting to that formula, here we go. So, like I said, sometimes it's useful to find the sum of some terms in an arithmetic series. This is another formula that they will give you on the test. They'll give you a formula sheet, and this will be on there. So, S is going to represent a sum. With the terms, we represented those with A's. S is the sum, so S of some number of terms is going to equal the number of terms divided by 2, where A1 is the first term and AN is the term of whatever it is the sum you're trying to find. So if you're trying to find the sum of the 50th term, you need to know what the 50th term is. And so this one is going to be a little bit more challenging than the last formula because that AN comes from using this formula. So anytime they ask you to find the sum, you're going to have to use both of these formulas to find that. So let's do a couple of examples where we have to do that. So we want to find the sum of the first 100 terms of the sequence. I'm going to write down my formula. Sn equals n over 2 a1 plus an. So I'm trying to find S100. So that means n is 100 here. A1 is easy to look at. It's just 1. And then I'm looking for A100. And so I need to go find what A100 is. And so I do that by using my other formula, which is A1 plus n minus 1 times d. So A100 is just going to be 1 plus 100 minus 1. And then the common difference here that I'm going up by each time is 2. And so then I would just plug that in and find what A100 is. You can do that. I will go ahead and tell you that A100 is going to be 199. And so then I'm going to take this 199 and plug it in right here for A100 and just solve that. So then S100 is going to equal 100 divided by 2, which is 50, times 200. I'm just going to go ahead and plug that in. You can plug it in exactly like you've got it. So 100 divided by 2, 1 plus 199, and that's just going to be 10,000. So the sum of the first 100 terms of that sequence is 10,000. Alright, let's do one that involves one of these old lady claws here. So find the number of terms, the first term and the last term, then evaluate the series. So this sum, I know some of you are probably getting real tired of writing these sums out on your assignment that you did with that. So this is a lot easier way to do this. First of all, I would need to generate a few terms to make sure this is arithmetic and that I could use that sum formula, because unless this is an arithmetic sequence, I cannot use this sum formula. This sum formula is only for an arithmetic sequence. So I'm going to just generate the first couple of terms here to make sure I can do that. So 5 times 1 is 5, minus 9 would be negative 4. 5 times 2 would be 10, minus 9 would be 1. 3 times 5 would be 15, minus 9 would be 6. And so I'm going to look and see what I'm doing each time. I'm adding 5 here, adding 5 here, so it is going to be arithmetic because it's going to follow that same pattern. And so I'm going to use this formula, S. Now, 25 would be what I'm trying to find the sum of, because I'm going from 1 to 25, equals 25 divided by 2. Now, the number of terms, that's 25 here. So we found that by looking at the 25 on the top. The first term I would find like we just did. We plugged in 1, and so A1 is negative 4. And then the last term is going to be A25, and I'll show you how we'll find that. Let's go ahead and plug in negative 4 right here. And then I'm going to do plus. Now, AN would be A25, and so that's what I'm looking for right here too. And so I'm going to go use this other formula. A25 is going to equal A1, which is negative 4, plus N minus 1, 25 minus 1, times the common difference. And the common difference here is a positive 5. And so I'm going to go plug in this to my calculator and see what I get for the 25th term. So negative 4 plus 25 minus 1 times 5. Ooh, I need colors that parentheses. And so then I get 116 as my A25 number. So I'm going to plug in 116 right there where that was. And so then I'm just going to type this in to get the sum. So, and then that would be evaluating the series when I actually go find the sum. So I'm going to do 25 divided by 2 times negative 4, 116. And so that's going to give me 1,400 for the sum of those 25 terms. And so then I found everything I needed to. The number of terms is 25. The first term is negative 4. The last term is 116. And then I evaluated the series. So that's how I would do that one. Alright. Now let's go ahead and write, it says use summation notation to write each arithmetic series for the specified number of terms. And so when I'm going to do these kinds of problems, I am going to first draw my old lady claw. And so I is going to start at 1 and go to 7. Alright, so then this, and you could also see this will probably be, since they gave us our variable n will be 1, and we'll go to 7. And so now I need to find, just like we had over here, I needed to find a formula that represented this sequence. And so this is just kind of like an explicit formula where I can plug in a number and get the term. And so basically I just need to write an explicit formula for this, and then we'll check it, make sure we got it right. So I'm going to look and find what these are going up by every time, and that's 2, and that goes in front of n. And so then remember, in explicit, we want to be able to get from 1 to 1, 2 to 3, 3 to 5. And so 1 times 2 would be 2, minus 1 would give me 1. So let's check it. 2 times 2 is 4, minus 1 would give me 3. 3 times 2 is 6, minus 1 would give me 5. And so if I were to evaluate this sum, let's just go check and make sure we got it right. So if I were to plug in 1, we already said 2 times 1 is 2, minus 1 is 1. If I plugged in 2, that would be 4 minus 1 is 3. 3 would be 6 minus 1 is 5. And then I would go all the way up to 7. And so all it wanted me to do was write this summation notation. And this is going to be the representation in summation form. Alright, let's do the same thing for part B. So I'm going to draw my little old lady claw here. And so then n is going to equal 1, and up here I'm not going to write an n, I'm just going to write 6. Alright, so then I need to find my explicit formula. So I'm going to label these 1, 2, 3. They're going this time down by 3, so I would need to write a negative 3 in here. And then 1 times negative 3 is negative 3. And then to get back up to 10, I'd have to go 3 out of the hole and then 10 more, so I would really be adding plus 13. Let's check this and make sure that it's correct. So then 2 times 3, or 2 times negative 3 would be negative 6. And so then negative 6 plus 13 would give me 7. 3 times negative 3 is negative 9. Negative 9 plus 13 would give me 4, so this is right. So this is my summation form. Alright, let's do one example of a word problem for sums, and then I'll give you some problems to try. It says your grandmother has assets of $350,000. An option that she's considering involves nursing home care for a 6-year period beginning in 2001. The model, this, describes the yearly nursing home costs in years after 2000. So does your grandmother have enough money to pay the facility? So we basically need to find how much all of those 6 years are going to add up to be. And so what I'm going to do is find the sum of 6 years. And so I would have 6 divided by 2. The first year I'm going to find by plugging in 1. And so 1,800 times 1 plus 49,730 is just going to give me, if you plug that into your calculator, 51,530. So 51,530 is how much it's going to cost her to live there in 2001, or in that first year. And so then I'm going to have to add that to whatever it's going to be in the 6th year, A6. And so then I would just simply plug in 6 where I plugged in 1, plus 49,730. Then I'm going to plug that into my calculator. Let's go plug that in. So when I do that, I'll have 1,800 times 6 plus 49,730, and that would give me 60,530. So 60,530. And so then I'm going to go ahead and plug this in and see how much the sum of all of those years would cost, and see if I have enough or my grandmother has enough to cover it. So then I'm going to plug this in. 6 divided by 2 times 51,530, plus I'm just going to do the second answer so I can get that 60,530 there. And then that's going to be 336,180. So sum of 6 years would be 336,180. So yes, she has enough to pay the facility. She wouldn't have a lot left over, but she does have enough to pay for those 6 years. So how much would it cost for nursing home care in a 10-year period? I'm going to do the same thing. I'm going to find S10. So that's going to be 10 divided by 2. A1 is still 51,530. And for time's sake, I'm just going to go ahead and tell you that it would be 67,730 for the A10. And so that's going to be $5,960 or $596,300. So she would not have enough, but this is how much it would cost her.